Hi, today we're going to take a look at this little PCB, which is advertised as a mini UPS board, designed for providing battery backup to small, low-power devices, such as routers, cameras, that sort of thing. There's no brand name on it, nor did it come with any instructions, but basically it takes a 5 to 12 volt input. It will output 9 or 12 volts, depending on the configuration of this little jumper here, marked JP1. So all you do is just put a bridge of solder across it, or take the solder off. You connect a single 3.7 volt lithium cell to the two battery points here. In theory, when the power goes off, it will output the desired voltage. It's rated at 12 watts, so in theory it can only provide an amp. Now, board, like I said, doesn't come with any instructions, nor does it come with an LED, so I've had to fit one. It takes a common anode, wide core LED. In this case, I put a red and green one on. If you look at the board there, you can see that red goes to the top, green to the bottom. Now, I did a bit of digging, and I found a couple of sellers on AliExpress with some contradictory instructions on what this LED does. One of them says you mustn't run this at full load for extended periods of time. So, although it's advertised as a router backup solution, I wouldn't actually recommend it, because most modern routers will take 2 amps, especially the ones with multi-core processors. This thing can only provide an amp, so if what they're saying is true, really you're looking at half an amp output. You want to run it continuously. Status LED, from what I can gather, lights up red when it's charging. It will go out when it's charged. Flashing red indicates a defective or not connected battery. Green indicates presence of a load, and flashing green indicates no load, but means power is present, or something like that. So let's solder some wires to it in a cell, and then we'll have a mess about with it. Right, so what I'm going to use for the input is a standard 12 volt adapter. Use this barrel jack connector as your input. Nice if it came with some instructions, so you got to do a bit of research to see what the steps everything means. So it is advertised as a router UPS board. Modern routers take about 2 amps because they'll have high performance processing nowadays to cope with the extra speed. They're like what wireless AC 1900 gives you. I mean, if you're running a standard ADSL modem, it'll probably be okay. But what we'll do is we'll load test this and just see what happens. It might get burning hot, you don't know. The other concern of mine is it going to be continuously charging the battery? Because the lithium batteries left on float charge is not good. One thing, it shortens the lifespan of the battery, keeping it fully charged all the time, and the other thing is it's a potential fire risk, so that's something we want to check. Make sure that even though mains is present, it does actually turn off the battery when it's charging, when charging is complete. Because otherwise that's a bit of a no-no, so we'll be checking all that. So let's get these wires soldered on. Let's hit input. And we're using a 12 volt input on this. Now I don't know whether this is configured for 9 volt output or 12 volt output, but we'll soon see. And I have to do with my helping hands here. Right, this is wobbling about all over the place. A good solder joint there, yep. That's your input taken care of. The output we usually use a standard barrel jack connector. I just need to figure out if the white stripe's positive or negative. So, slowly meter. Yeah, a bit dubious with these lithium, like so-called UPSs. I mean, lithium by nature doesn't like being forward charged, as I said. And then make sure it does actually knock off the charger. Looks like negative. White stripe's positive. Yeah, there we go. The white stripe's positive. One thing you've got to be careful with is that it's a lot of equipment. White stripe's negative. Right, what should we get? Make sure this is right. Out negative. Out positive. So yeah, this came from Amazon, this particular board, but there's no let's say I didn't even provide any instructions. Come on. So what we're going about. Alright. I don't know what I'm going to do now. Let's plug it in and see what it does. Yeah. So I've got standard UK 12 volt adapter here. I reckon that's that from our previous video. And then we'll plug it in. Right, flashing red. Okay. Indicate, yep, there's no battery present. Alright. Oops. Before has not signed. Right, okay. Voltage. What do we have on the output? 14 volts, okay. Yeah. What's the input voltage? And get room in there. Let's plug it back in there. Input voltage. Right, well the input voltage is actually 14, so I think what I need to do here is get an AC adapter that actually puts out the right voltage. Right, probably because there's no board on it, but I just got another one. Yeah, that's about like it, 12 volts, right. Oh, I presume that jumper is set to 12 volts then. So if the blob is soldered across it, it's 12 volts. If it's unsoldered, it's 9. We'll test that theory by unsoldering it and see if the voltage changes. I don't think it was outputting 14 volts, so the input was 14, so it doesn't look like it's actually regulating the output voltage at all. Maybe the output voltage is only applicable when it's on battery. Yes. Doesn't look like it. One moment. Okay, that's the PCB trace broken, so plug it back in, flashing white again. Do we get on the output? 10 volts. Okay, so it does regulate it down. Right, there we go. Right, so I'm going to set this for 12 volts though, so I'm going to resolder that back up. So yeah, jumper open 9 volts, jumper closed 12 volts. Right, that's that reconfigured for 12 volts. Alright, battery. For the battery, I'm going to use this Samsung mobile phone battery. Probably not the best thing to use, but I just need to solder some wires on here now. And then solder it to the board and see what happens. I'll come back. Let's get these wires soldered on. Let's extend them a little bit because they're a bit too short. Just before I look at the board, I'll just show you what chips are on these. You've got an unidentified chip there, which is ALB GFA. You've got TP 4056, something like that, I think it is. No, it's not. Basically, these are the two chips. That's your boost converter chip, and that's your battery protection IC. That is an unknown device, probably MOSFET switch or an op-amp that tries the LED down here. Yeah, so right, let's get this soldered on. Right, that's the battery prepared. Shut the thermal sensor off. Don't need that. Single cell battery. So, right, I'll solder this to the board now. Are we going to get sparks? B minus that side. Safety first. Oh, solder one wire at once. Oh, that's a good one there. B pushes that one. I want to solder that one up wrong one. That would have been good, would it? B minus, B plus. Yeah. Well, no spark when I connected it, so good start. Right. Other way, so let's short anything out. Right, that battery connected. Do we get an output voltage? We do. 12 volts. So it does work. Notice that the LED is off. Now, that lithium battery is going to do a switch on it because that is permanently connected. So if you do want to switch this off, you're going to need to put a switch on the lithium battery so you can disconnect it because the output is always on. Right, okay. Move this forward line out of with. Yeah, having something you can't turn off, it doesn't really appeal to me. So, right, lights come on to 6 indicating it's charging the battery. Output do we have? 12.13, unplug. 12.15. How bad? Right, so I need to do is put a load on it now. Look, the green LED is off. It said something about it flashing, but obviously this thing will be providing power to the charge circuit, so I need to make sure the AC input can handle. Make sure the AC adapter can handle both charging the current. Needs to be able to handle charging the battery and the load at the same time. So ideally, you need to use a AC adapter that has a minimum of 12 volts at 2 amps. Alright, so that is working, and it's working off the battery there. So plug that in. So it's now on mains. And the green light don't work though. Unplug that. Well, obviously the green light is supposed to come on according to the AliExpress listing, but it doesn't, so yeah. So what voltage do we have? Oh, the output, no. $11.63. Well, unplug that. $12.07. This isn't working. Well, this clock ticks about half an amp, so notice that green light is supposed to come on, but it ain't doing so. Unless the green light comes on when it's charged. Yeah, I guess as good as mine at the moment. This Chinese stuff, battery voltage. It's charging the battery. So I think what we'll do is we'll leave that and see if that fully charges the battery. What we don't want is to leave it on float charge. Yeah, right, come back then. Okay, so it's later in the day. This thing has been on charge for quite some time, and the battery voltage is at 4.1 volts. I've looked at the datasheet for the chip. Battery protection I've seen is cut-off voltage is 4.15 volts maximum. So it's 4.11. So that should knock off any moment. What I want to do is make sure it's not float charging the battery continuously, because that is bad for lithium batteries. So yeah, just leave that a little bit longer, see what happens. And so far it seems like a good little board. The idea for putting inside equipment where you need battery backup rather than actually using it for a router or something like that. Idea for electronics projects or sensor projects where a power failure would be a problem. You can actually put it in the device using a small lithium cell. Yeah, so far it seems okay. I might buy another. So I've got another battery pack I can mess about with. I've got another one from an old tablet, which is supposed to be 10 amp hour, but it measures 5 amp hour, so it's still usable. We're up to 4.12 volts now. Right. Battery is cold. Right, give that a bit longer. Here's the other battery I just mentioned. So it's salvaged from an old faulty tablet. And it is dated 2011. This video is 2024, so it's quite old. But it's still got half its capacity left. So I mean, that's possibly still usable. haven't turned into a spicy pillow yet, so salvage a few more of these. The other option is use 18650. That's probably a better idea, to be honest. But a lot of them are dubious. I mean, you can salvage them from old laptop battery packs and things like that. So you make yourself a cheap UPS. Right, let's go back to the original one. Give that 10 minutes and I'll come back. Right, okay. Battery voltage is at the point where it should cut off. 4.14. It's supposed to cut off at 4.15. It's not doing. That is supposed to disconnect the battery at that voltage, so it's looking like that might be an epic fail. It's going to end up overcharging the battery. You probably wouldn't want just leaving this plugged in all the time. Yeah. Right, well, I'd leave that a little bit longer. If it reaches 4.2 volts and it hasn't turned off, then the battery protection circuit isn't working as it should do. Right, well, I've just looked at the data sheet. The overcharge detection voltage is 4.2 to 4.25 volts, and the overcharge release voltage is 4.15 volts. So what it should, in theory, do is charge to 4.2 volts and then switch off. But it seems like it is trying to overcharge it, to me. Whether the chip's faulty or not, I don't know, but looking at the data sheet, say the battery voltage gets to 4.25 volts, it will then disconnect the charging circuit. The battery voltage will then start to drop, even when it's not on the load, because it will begin to back off a bit, and when it gets to 4.1 volts, it will turn the charger back on again, so it's going to perpetually keep the lithium battery float charged. Like I said earlier, that is very bad for lithium batteries. It greatly shortens the lifespan of them, and it could be a potential fire risk, so this is not something I really want to leave plugged in all the time, because it's keeping the battery fully charged. Charges it to 4.2 volts, drops to 4.1, turns the charger back on again. What is that beeping? That beeping meter, but it can't be the charger. So see what voltage we're at now. See, it's at 4.17. Yeah, nice. Leave it a bit longer, and then we'll make a final conclusion on it. Okay, I'm going to make some final conclusions on this now. I've been monitoring the battery voltage, and it seems to be not getting any higher than 4.1735. It just goes to 3.6, and then it just won't charge any further. There we go. So it's slowly increasing, but I think that battery is now fully charged, and it is still charging this very slowly. It doesn't look like it's going to disconnect it. So yeah, this thing is constantly full charging the battery. So it works. But I think the final conclusion is I'd be concerned that it's leaving the battery fully charged all the time, float charging it, which, as I said before, lithium batteries don't like that. So it is what it is. It's cheap, but I wouldn't be putting it in your house, because if that battery goes nuclear due to being overcharged, it may cause a fire. So yeah, I think that's the final conclusion on this product. it's meh, yeah. So yeah, use it, but don't use it for anything mission critical, and you should be fine, I think. I think that just about wraps it up. Thanks for watching.